Hello and welcome to the answers to the CASE 2009 February paper. A little talk through of the answers which are also attached on my website. Question 1 is adding fractions with mixed numbers and multiplication as well. When you add these, because the whole numbers it's an addition, you can add those and then think about the common denominator, which is 12. And remember, don't leave your answer as a mixed number, sorry, as an improper fraction. You've got to make it into a mixed number. Part 2, remember to do the multiplication first. It is a BIDMAS question with fractions, so make sure you make the mixed number into an improper fraction, do the multiplication first, and then common denominator and solve. Being very careful when you do 3, take away 5, you've got -2/15, so you take 1 away from the whole number, and that's left with 13/15. Question B is not on the answers for some reason, but 2/5 of 60 is 24. 26% of 50 is 13. 26 divided by half is 52. And 25% of 60, which is a quarter, is 15. So in order of size, in ascending order, so you start with the smallest is 26%, followed by 25% of 60, followed by 2/5 of 60, followed by 26 divided by half. Remember, when you divide by less than 1, it gets bigger. For question 2, it's about angles, remembering your angle rules. P is on a straight line with 69, so you've got to sum up to 180. It is a quadrilateral as well, so Q, this one here I've called it Q star. Q star is 360, take away the sum of all these, and then Q is whatever you need to make it a straight line, which is 180. In part B, it is a regular polygon. The exterior angle, looking at 150, the exterior angle with that is 30, which means you've got 12 lots of 30 to make the exterior angles sum up to 360. So it has 12 sides, so it's a dodecagon. R is part of an isosceles triangle. You've got 2 sides which are equal, one of them is 150, so the other 2 must be 15. If we know that's 15, we can take it away from 150, the total interior angle, which leaves S as 135. And then the last bit, if you look, it's a pentagon. There may be other ways, but the pentagon, the sum of angles in a pentagon is 540. 3 of them are 150, and we've got 2 left, so you take 540, take away 3 lots of 150, divided by 2, and you get that T is 45. But like I say, there may be other ways of getting there, that's just the way I used. Right, question 3 is substitution. Just take a lot of care of these ones, especially with the negatives. When you subtract a negative, you're really adding it. So 2a plus b, it's 24 minus 3, 21. A squared, when you take away the negative, remembering BIDMAS here, so do them in the right order. 144 plus 6 divided by -15, which leaves you with -10. Remember again with those negatives, if there's -5, or if there's a negative number in front of the brackets, remember to multiply them both by that negative, or the signs change inside that bracket. So here, when you multiply out here, this is the important one, you've got 15c plus 15c squared. Next one, write it out, look to see what you can cancel, make sure you cancel fully. So you've got 36 divided by 9 is 4, you've got d squared, you can cancel one of these as well, so you get 4d squared e. Part C is about inequalities. Remember, get your x's on the positive side for this one. They already are, so leave them there. When you take away 65, you're left with 22 divided by 4. Remember, leave your answer with x on the left, but don't forget to switch your inequality sign around when necessary. Part B, get rid of the denominators by multiplying every term by 4. Cancels with the one on the bottom there. And remember, both of these, 3 and minus 2x, they both need to be multiplied by 4 as well. Collect like terms, get your x's on the left, numbers on the right, and you end up x is greater than a half. So the square numbers that are less than or equal to 5.5 or greater than a half are 1 and 4. Question 4. There's a separate sheet to fill in this one, which is attached at the end of the answers. We'll quickly look through the answers here. They both arrive after him. There's 6 times when that happens, 6 out of 20, which is 3/10. When George is on time, Fred is on time, George is late. Well, there are 10 times when Fred is on time, and George is late for 6 of those, so it's 3/5. George on time, Fred late. 8 times when George is on time, Fred is late for them, so it's a half. So if you're a boss and you were on holiday for the whole of Feb, who would you give your keys to? You would say Fred is late half the time, George is late 12/30 of the time, so Fred is late less days, so I'd give it to Fred, probably. Or also, when Fred is late, George is normally late too. So, yeah. Any way you can explain that coherently, but I think Fred is probably your best bet for that one. Right, question 5 is a ratio one. Remember to show your full working here. A, B and C, 7, 5, 4, and that's where everything starts from. If Amy's has 45 more than Colin, at the moment the difference between A and C is 3, so we need to multiply. The multiplier is 15 for this ratio, so then would be 5 times 15, which is 75 albums. And altogether, if you add them up, 12, 16, you do 16 times 15, which is 240 albums altogether. Again, for this one, get down your key information. D is 2/5, Eliza, E, is 27, and Francis there must be 9, because Eliza ate 3 times as many as her. So how many were there at the start? Well, Eliza and Francis is 3/5 of X. I said that X is the number of chocolates in the bar, in the box. 36 is 3/5 of X, and then you can work out either by dividing by 3/5 or timesing by 5/3 or some other way, that there were 60 in total. And make sure you check that, because 2/5 of 60 is 24. 24 plus 36 makes 60, so it's got to work. The percentage that Eliza ate was 27 out of 60. There's your fraction. Multiply it by 100 to make it a percentage, and you get 45%. Okay, number 6 is about very odd numbers. It's a very odd question, and there's quite a few marks on offer here, so let's see how you did. The 4 bonds between 100 and 120, just be really careful that you read it carefully and you understand what a bond is. It's probably one you might leave until the end, because it's a bit unusual, or you might give it a go because you like these kind of new problem-solving questions. The 4 between 100 and 120, 111, 117, 119 and 113. So just by trying them out, you can work them out there. Explain carefully why I can't have a 5 as a units digit. I've said here, we can read what I've said. An example is always good to show why I can't end in 5. Write down the only two bonds between 121 and 149. I seem to have missed that out for some reason. So there's only one mark. So it can't end in 5. It can't have an even digit in it. So we're looking at 133 maybe, 137 possibly. They might be the only two, or 139. Work them out. I'm sure you can. The 8 bonds between 150 and 199. 100's got to be all odd. So there they are there. And I've explained on some of them why they can't be if it ends in 5. I've just shown that. If the middle digit is, if the tens is 5, that can't be 1. Then question 5, part 5. While there are no bonds, so read carefully what I've written. Obviously you need to explain it some way. Examples are good. Make it clear. Reread your answer to make sure you can follow it. And then part 6. How many 3-digit bonds there are. This is the kind of question where you might say, okay, I'll come back to that at the end. It'll take a bit of time to get used to. But I've gone back to all the previous parts of the questions. Really, I only had to work out how many there were between 300 and 399. And I reckon that was 12, which would be the same for 500 and 599. So there's 38 in total. Right, question 7, you see a right angle triangle and immediately you should be writing down a squared plus b squared is c squared, because it's obviously going to be something about Pythagoras. Make sure you show you're working out clearly. AD squared is the difference between the hypotenuse AB squared and BD squared. So show you're working out clearly, make it 5. For BC squared, again, that is the hypotenuse, so it's sum of the squares of the other two sides. So make it clear which one your hypotenuse is. So the area of the quadrilateral is the area of the big triangle, the whole triangle ABC. Take away the area of AEC. Now AE is the midpoint of BD, so it's half the height of this. 6, so area of the triangle is half base times height. Take away the area of AEC, and that makes 42 centimetres squared. Important point there, don't forget your units. You probably won't lose marks for it, but do be sure that you do show them. I must have been in a rush when I was doing this. Right, B to point F on the line AC in such a way the perimeter is equal to that, so they're both equal perimeters. So I said, let that distance, F to C, equal X. It's an unknown quantity. So if I said that was X, that meant that AF was 14 minus X as well. Now, because they share the line BF, we don't need to include that in their perimeter, because it's a shared line and both have that quantity added on. So if we say that the area of BAF, 13 plus 14 minus X, has got to equal BCF, which is 15 plus X. So you make those equations, solve them, you get that X is 6, so the ratio is 8 to 6. Simplify it, make sure you simplify your ratio, 4 to 3. The classic case there, where if you unknown quantity, use X to represent that quantity. Right, number 8 is a circle question. It's roundabout sign, and all measurements are in centimetres, so again, don't get your units. Leaving your answers in terms of pi, so that's important there to note. Don't approximate it or use 3.1 or whatever, leave them in pi. And so you're treating pi as a variable, it's got to be in like terms for you to simplify or anything like that. Sec p, it's quarter of a circle, quarter times pi times the radius squared, which gives you 100 pi. Again, you can look at p and q together, same thing, it's a quarter of the area of the whole circle, so quarter pi r squared. And the area of semicircle r, sorry, q next, so the area of q is the whole thing, take away the area of p, so that's 300 pi. The area of r, you know that the radius of r is 10, so again it's half a circle, half pi r squared, gives you 50 pi, so the total black area is 3 lots of, there are 3 of them going around, 300 pi the area of q, plus 50 pi the area of r, and that gives you 1050 pi centimetres squared. So the percentage, to write a percentage, it's the area of black over the total area. You need to quickly work out the total area, pi r squared for that, and then percentage. Simplify, you can cancel your pi's here, you can cancel a few zeros, and you're left with 42%, which is black. Okay, bizarrely number 9's on the back, so we'll go to that one next. Jack's got his coins, so if he's got a 10p coins, the value of the 10p coins is 10a, the value of the 2p coins is 2b, that sums up to 160, be careful if it's in pounds or pence that you're using. To simplify the equation, you can divide everything by 2, and you get 5a plus b is 80. So you're filling in that table as we go. Number of 5p coins. At the start he had no 5p coins, and he took out half the number of 2p coins, so he took out b 2p coins over 2, just b over 2p coins, and he put in that number of 5p coins, so 5p coins is b over 2. For the number of 2p coins, same thing, he's taken out half of them, so he's left with b over 2. Feeling that being too generous, took half the 10p coins out and placed them with the same number of 5p coins. So again, half of a is a over 2, so he's got a over 2, 10p coins left, and therefore he's got a over 2 plus b over 2, 5p coins, or whichever way around you want. So when he recounted, he found that he had £1.40. So the total value is 10 lots of a over 2, that's the 10p coins, 5 lots of b over 2 plus a over 2, that's the 5p coins, and 2b over 2, that's the value of the 2p coins. And all of that together adds up to 140p. Simplifying, looking to see what you can cancel, multiply everything by 2 to get rid of the denominators, collect like terms, and you end up with what they want, 5a plus 7b is 280. Now, the easy bit, solving two simultaneous equations. There they are, go right back to the first part, 5a plus b is 80, 15a plus 7b is 280. I made the a's the same, the coefficients of a the same, 4 minus 3, b is 10, a is 14. So the smallest, if the number of 5p coins is that, so the maximum amount is £2.20. Put that one there. So it's smallest minimum amount. Minimum amount. Okay, so number 10 is done on the separate sheets as well as the first part on here. The area of the shaded arm is area of rectangles base times height, so just make that clear. The width is 6 minus x, the height is x, so it's x lots of 6 minus x, 6x minus x squared. If the area is y, you've got 4 lots of the arms plus the centre, so you've got 4 lots of what you've just worked out, plus x squared, which is the area of the centre. Multiplying out, collecting like terms, you get that y is 24x minus 3x squared. So you've got what they wanted you to show. In the graph, be careful when you're filling in these values. You'll notice in this one there is a repeat, so it will mirror about x equals 4, but just be careful when you're squaring a negative, you get a positive. When you times that by negative 3, you'll then get a negative. So be very careful with your squaring negatives there. Your grid graph should look a bit like this. A nice curve, which you plot points carefully. If it's not a curve, it means you've made a mistake and you need to go back and check your squaring or your negatives, whatever it may be, that has meant you've got a bit of a kink in your curve, and the kinky is wrong. One decimal place, smallest value for x, with an area greater than 35, where if you draw a line from 35 and drop it down, you get 1.9. Give it to one decimal place. Yours might be slightly out, depending on how well you drew your curve. Okay, add up your marks, and don't forget to bring that in at the beginning of next term. Have a happy Christmas and a wonderful 2014.